Lesson 3-1, Graphing Linear Equations. A linear equation is one that forms a line, because we see the word line in the word linear equation. It's an equation that forms a line when it is graphed. There's a form that we typically see the equation written, and it is called standard form. And that form is here. You have ax plus by equals c. C is the constant, and the ax and the by are considered variable terms. And this will make a little bit more sense as we continue through with this lesson. But this is the way that it needs to be written for it to be in standard form. Sometimes you might be given it written in a different form, so something like this. And in order for it to be in standard form, your x and your y have to be on the same side together, leaving that constant open. So the first step with linear equations is writing the equation in standard form. So let's take a look at that example. Y equals 4 minus 3x. So we want to have the x and the y on the same side of the equation. So we can do that by adding 3x to this side. So you would add 3x to the other side. So now we have 3x plus y equals 4. So we would be able to say that this equation is in standard form because we have the x and the y that is equal to a constant. Pause the video to write the examples below in standard form. The first example, 8x minus 3y equals 6 minus 4. So we do have an x and a y on this side, but we still have an x over here. So you want to get that to the other side, so you add x to both, 4x to both sides. So your new standard form equation is 12x minus 3y equals 6. Next equation, 7x plus y plus 3 equals y. So we need to get the y to the other side, but we also need to get the 3 to this side. So let's start with the 3. We subtract 3 from both sides. So now we have 7x plus y equals y minus 3. Now we can subtract y from both sides. And so we are left with 7x equals negative 3 for our new equation. So once you have your equation in standard form, you have to determine if it is truly a linear equation. So the previous example we had ended with 7x equals a negative 3. To determine if this would be a linear equation or not, you would be able to solve for the y, or for the x, and you would get x equals negative 3/7. So if you graphed that point, then you would be able to get a straight line, making it a linear equation. Now, if we have an equation that starts out 4x y plus 2y equals 9. Right at the beginning, you would be able to say that this is not a linear equation because we have two y's over here. And we're not able to combine them because one of them is an xy. So you have your constant and you have your x and y on the same side, but there's an extra variable that's not able to be accounted for. So this one would not be a linear equation. Pause the video to determine if the equation is linear. So your first step is to get it in standard form. So we're going to make sure that our variables are on the same side. So we're going to add 2m. And so we're going to be left with 7n minus 6m equals 4. And just by looking at this example, we would be able to assume that it would produce a linear graph or a line graph because we have one variable with a constant. So we would say yes. The next example, you should be able to look at it right away, and because we only have one variable and that one variable is squared, so there's 2 of one variable, we are able to say no, this would not produce a straight line, so it is not considered a linear equation. So let's take a look at finding intercepts based on information that we're given. The example is the Torres family are driving to an amusement park. The table shows the function relating the distance to the park in miles and the time in hours they were driven. Find the x and y intercepts of the function. Describe what the intercepts mean in the context of the situation. So we're first just going to kind of sketch out a graph. And they say our time and our distance, so is what they've given us. So in 0 hours, we have traveled, so let's put the distance here and the time across the bottom. So in 0 hours, we have traveled 248 miles. So let's count our graph by, let's count by 60s. 60, 120, 180, 240, and 300. Okay, so our first point would be at 0, 248. So 0, 248. At 1 hour, we would be at 186. So at 1 hour, we're going to be at 186. 2 hours, we're going to be at 124. At 3 hours, we're going to be at 62. And at 4 hours, we would be at 0. So if we do this to make our line, our x-intercept is where does the line cross the x-axis. So on this graph, it's right here. So we would say that the x is 4. The y would be here. So that would be 248. Now I want you to describe what this means. So what this means is that at 4 hours, they are not traveling any distance, which means they have arrived at their destination. At 248 miles, they have just started, and that's the total distance that they have to travel. So we can also graph by using intercepts that we can find with a linear equation. So when your linear equation is written in standard form, you can solve for your x and your y by replacing each one of those with 0 and solving. So let's say, for this example, we're trying to solve for x. So that means that we have to set y equal to 0. So if we do that, that gives us 2x plus 4 times 0 equals 16. So 2x equals 16, so x would equal 8. So that means that the x-intercept, where the graph intercepts the x-axis, is at 8, and the y would be 0, would be your coordinate points. If we're solving for y, then you replace x with 0, because the x-intercept is at 0. So we have 2, 0, plus 4y equals 16. So then you're left with 4y equals 16, and your y is 4. So when you write your coordinate points for your particular graph, you would have 8, 0 to represent the x coordinate, and you would have 0, 4 to represent the y coordinate. So if you wanted to graph this out to figure out what this would look like, your x point would be at 0, 8. So it'd be right there. And then your y point would be at 0, 4. And then you can just graph a line connecting the two. It goes on and on forever. And that would be the line of the equation 2x plus 4y equals 16. You can also graph a linear equation by making a table. When you're making a table, you can really replace your x and your y with any number and solve to get your coordinate points. So if we had a table and my x, my y, and then my xy, so my coordinate points, and in between was my equation. So let's say we have the equation 2x minus y equals 2. You can use any number that you want to complete this table. I recommend that you use a few negative numbers and maybe a few positive numbers. So let's start with -3 for x. If I put in -3 for x, I have -6 minus y equals 2. So I would be able to add 6 to both sides and get 8. Negative y equals 8. So then I would have a -8. So my coordinate points would be -3, -8. If I wanted to replace x with 0, my y would be -2. So I would have 0, -2. Okay, again, you can choose any number you want, just as long as you're getting a few sets of points so that you can go and then you can graph the line to determine if it's a linear equation. Since there's a lot of information in this video, there will not be a kind of lesson review at the end. I would just encourage you to do as many practice problems as you see fit to give yourself some practice. This may be a lesson that you might have to do more than 10 to 15 problems, depending on what you need help with, whether it's graphing the line with a table, graphing a line with the x and y intercepts, finding the x and y intercepts, writing it in standard form. There's a bunch of different examples and different ways to use linear equations. So you may just have to select a section where you feel that you need the most practice. If that results in doing more than 10 to 15, that's okay.